Fifth question, prove the following identities. So these are somewhat lengthy questions and logical questions based on the three identities. From those we have several identities. These are also called identities. So we have a proof and result that is called an identity here. Now we have to prove this. Therefore proof, here this is LHS part and RHS. I am taking RHS here. Therefore RHS is equals to 1 minus cos theta by 1 plus cos theta. So denominator symbol you change and multiply. So in denominator we have plus. You take 1 minus cos theta and 1 minus cos theta. So numerator and denominator you multiply with 1 minus cos theta. This value will be taken based on the denominator, not numerator. Now you see this is 1 minus cos theta whole square by, this is a plus b into a minus b, a square minus b square. So 1 square is nothing but 1. Now the numerator is 1 minus cos theta whole square. The denominator is 1 minus cos square is sin square theta. So this is, we have an identity, that is 1 minus cos square theta is equals to sin square theta, put in bracket. So this is a used principle here. So now we have here square and here square. So in numerator we have square and denominator. So I can write 1 minus cos theta by sin theta whole square. Now this is nothing but I can write 1 by sin theta minus cos theta by sin theta whole square. Now this is 1 by sin is nothing but cosecant theta. Cosecant reciprocal is sin, sin reciprocal is cosecant, and cos by sin we have formula, that is cot theta whole square. You observe carefully, this part is nothing but LHS. So this is LHS. Therefore, hence it is proved. This identity is correct. Now question number 2, second identity, we have to prove that these two values is equals to 2 secant theta. Okay, for this, let this given question is some equation 1. Okay, now take this particular value cos A by 1 plus sin A. So I am preparing one of the value for this one. So I am not taking all the problem, cos by 1 plus sin. So this you multiply with the denominator 1 minus sin A, here 1 plus sin A. So you multiply and divide with 1 minus sin A. So that you see this value will become cos A 1 minus sin A by a plus b into a square is 1 minus sin square A. So 1 minus sin square A is nothing but, this is cos square A. So 1 cos will be deleted. Therefore 1 minus sin A by cos A. So here this particular value, what is this particular value I have taken, that is cos A by 1 plus sin A. So this value I can write as 1 minus sin A by cos A. Now you take the question, therefore by 1. So by 1 is nothing but it is a question. So this part you replace it by this one, that is 1 minus sin A by cos A plus, so this I am writing as it is 1 plus sin A by cos A. So this is LHS part only. Now take the LCM, that is cos A. Now the numerator is 1 minus sin A plus 1 plus sin A. So both will be deleted. It will be 2 by cos A. Therefore I can write 2 into 1 by cos A. Therefore 2 into 1 by cos A is nothing but secant A. This is RHS. Therefore, finally, I got LHS is equals to RHS. Therefore, hence proved. Now, third question is this part is equals to 1 plus secant theta and cosecant theta. LHS is in terms of tan and cot. RHS is we have secant and cosec. Okay, for this I am taking tan theta, that is LHS I am taking. This LHS is equals to tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. Now you see tan theta by the denominator 1 plus cot, I am writing cot is in terms of tan theta and plus cot again in terms of tan theta, 1 by tan theta by the denominator is 1 minus tan theta. Now this is numerator tan theta as it is. By here this part you take the LCM, that LCM is again tan theta, it will become tan theta minus 1, whereas plus this I can write 1 by, this is tan theta, this we can write denominator here and it is again 1 minus tan theta, this is as it is. You see, don't get confusion, this is we have by 1, if I take reverse also I will get the same value. Here whenever the numerator consists one of the denominator, we can write the denominator directly here. Now this is, you see I don't have here, let 1 is the denominator. Now it will be reversed as tan square theta by this I can write tan theta minus 1 plus here 1 by tan theta into 1 minus tan theta. Okay, if I take minus common here, what happens we'll see. Otherwise you take minus common here. So in part, if I take minus common here, this will be as tan theta minus 1. Why? Because here tan theta minus 1, here tan theta minus 1. I required this value. But the previous step we have 1 minus tan theta. So I took minus as common here and it will become tan theta minus 1. Now here plus into minus, it will be minus. Now you see tan square theta by this value is tan theta minus 1 and plus into minus minus 1 by tan theta into tan theta minus 1. Now here the total I can take tan theta minus 1 as common. Now remaining is tan square theta minus 1 by tan theta. Now this will become 1 by tan theta minus 1. This is, if I take the LCM, it will become tan theta, and again this is tan cube theta minus 1. So to here, just remember, note down, we'll continue, and I'm just removing this area. Now this part I am writing here, continuation, that is 1 by tan theta minus 1, and here this is tan cube theta minus 1 by tan theta. Just note down this one. I am removing this part also. Okay. Now you see this part I can write a cube minus b cube. So 1 I can write 1 cube. A cube minus b cube, we have a formula. a minus b into a square plus ab plus b square. Now this is 1 by tan theta minus 1, and this is, I can write a minus b tan theta minus 1 into a square tan square theta plus ab. This is a and this is b. So tan theta into 1 tan theta plus finally b square is 1 square is nothing but 1 by the denominator is tan theta. Now see these two part will be cancelled. Now tan square theta plus 1. Here we use one identity 1 plus tan square theta 1 plus tan square theta plus remaining is tan theta by tan theta. Now you see 1 plus tan square theta is secant square theta plus tan theta by tan theta. Now just you divide it, write down secant square theta by tan theta plus tan theta by tan theta. So this will be cancelled, we'll get 1, and here we have secant theta, and check the answer once. We got 1 here and remaining secant and cosec. So 1 secant is required there, 1 secant, and remaining is 1 secant. That 1 secant I am writing as cos theta by tan is sin theta by cos theta plus this part is 1. Got it? This is, I am simplifying. In secant square, one of the value I wrote secant theta, and second 1 secant I am writing 1 by cos theta, and the denominator tan theta is sin by cos. This is, it will be cancelled 1. Now you observe cos will be get cancelled. Now secant theta into, I got in the denominator sin theta, that is 1 by sin theta plus 1. This is nothing but secant theta into 1 by sin is cosecant theta plus 1. So this is RHS part. Now next question is 1 plus secant A by secant A is equals to sin square A by 1 minus cos A. This is one of the identity. Here I am taking RHS, that is sin square A by 1 minus cos A. We have an identity sin square A is equals to sin square A is equals to 1 minus cos square A. This is first identity. So I am substituting this value here in RHS. Therefore sin square A is equals to 1 minus cos square A by 1 minus cos A. Now this is 1, we can write 1 square, that is A square minus B square. I can write as 1 plus cos A and 1 minus cos A by the denominator 1 minus cos A. It will be deleted. Now I got the value 1 plus cos A, but you check the denominator. Here we have LHS in terms of secant A. You convert into the secant. 1 plus cos, I can write 1 by secant A. Now take the LCM. So LCM will be secant A, and this is secant A plus 1. You see 1 plus secant A. So this value is LHS. Now LHS is equals to RHS. Now fifth identity, it is important identity. This value is equals to cosecant A plus cot A. So it is lengthy and tricky question. Just first divide, take LHS part, divide numerator and denominator by sine theta, sine A. Okay, therefore LHS will become cos A minus sine A plus 1 by sine A, and the denominator, this is LHS here, denominator is cos A plus sine A minus 1 by sine A. Okay, now you write directly cos by sine is cot A minus sine by sine, it will become 1 plus 1 by sine, it will become cosecant A by the cos by sine again cot A plus sine by sine is 1, 1 by sine is cosecant A. Now we have to show that by using this identity cosecant square A is equals to 1 plus cot square A, we have to use. Now what to do is just to change this 1, denominator you keep as it is. Instead of 1, I can write as what is 1, 1 is equals to here cosecant square minus cot square. Therefore cot A plus cosecant A, write at one place, remaining this minus 1, 1 you use this identity. So from this identity 1 I can write as cosecant square A minus cot square A, put a bracket. Now the denominator you do not change, keep as it is, 1 plus cosecant A. Okay, then what to do is, now this is A square minus B square. So first you write as it is, this is cot A plus cosecant A, and the second part, this is we have minus here, A square minus B square. So A plus B, A plus B and A minus B, cosecant A minus cot A. See, and the denominator keep as it is, no change in the denominator, cot A plus 1 plus cosecant A. Have you understood? Just this value I applied here, I expanded in A square minus B square formula. Now you see this is one term and these both have one term. Here this value is common, you check it. Now I can take common, that is cot A plus cosecant A. I am taking common. If I take common, this value will become 1. Because in these two terms I took this value 1 and minus of, when I am taking this value, remaining is, bracket is there, cosecant A minus cot A. You see, minus is there, minus of cosecant. So when I delete this bracket, minus of cosecant minus cosecant, and minus into minus plus cot A by the denominator. What is the denominator here? Cot A plus 1 plus cosecant A. Now you observe carefully what is happening here. Here in the denominator we did wrong, minus 1. Here you see minus 1 by sine is minus cosecant A, 1 by sine, and the denominator is minus cosecant here. Totally the denominator will have minus. Check it once. Don't get confusion. Minus 1 by sine theta is minus cosecant theta. Now you see these two are equal. You see 1 minus cosecant A plus cot A, 1 minus cosecant A plus cot A. It will be deleted. Now remaining value are cot A plus cosecant A. Cot is nothing but cos A by remaining value is the required answer. Once check it, we got cosecant A plus cot A. So this value is RHS. So now LHS is RHS. Hence proved. Just remember here I used this formula is 1 equals to cosecant square A minus cot square A. This formula, this identity I used. Here the condition is by using this identity we have to find out. This is the answer. You see simple, only 5 steps. 1, 2, 3, 4 and 5 steps. Now next question is square root of 1 plus sin A. Take LHS here. We have square root of 1 plus sin A by 1 minus sin A. So check the denominator. Multiply numerator and denominator. This keep as it is 1 minus sin A. So here you multiply with 1 plus sin A. Always take the reverse symbol of the denominator. So numerator and denominator must be equal. Now this I can write as 1 plus sin A whole square by here 1 minus sin square A. This is A 1 minus A and 1 plus A. Totally we have a square root. Now I can write 1 minus sin square is cos square theta. Now it will become square root of 1 plus sin A whole square by this is cos square theta. Why? We have the first identity 1 minus sin square A is equals to cos square A. Now I can write square root of 1 plus sin A by cos A whole square. So these two will be deleted. Now the remaining part is 1 by cos A. I can expand like this, and sin A by cos A. Now you see we have 1 by cos A is secant A plus sin by cos is tan A. So this value is RHS. So hence it is proved. Now this is one more identity to prove. Take LHS here. It will become sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. So here the note is we have to divide numerator and denominator by cos theta. You see, because we have in terms of tan. So sin by cos, it will be tan. So that what I have to do is sin theta minus 2 sin cube theta by cos theta. This is numerator part, and denominator also write down 2 cos cube theta minus cos theta. Now you see here sin by cos I can write as tan theta minus 2. This I can write sine theta by cos theta into sine square theta. You see sine cube we have. So I am writing sine theta into cos theta. Take one more step for that. And here the denominator, again this is also I am dividing by cos theta. So the note is here, divide numerator and denominator by cos theta. Now, but in 2 cos cube theta by cos theta is 2 cos square theta minus cos by cos will become 1. Let's okay. Cos cube by cos is 2 cos square theta, and this will become cos theta by cos theta will become 1. Now check it once. Tan theta, we have tan theta minus 2 tan theta into sine square theta. This is the numerator part, and denominator part is as it is, there is no change, in 2 cos square theta minus 1. Now you observe carefully. Here take tan theta as common. So if I take tan theta common, this is 1 minus, it will become 2 sine square theta by 2 cos square theta minus 1. Now what to do? So in answer we have tan theta. These two must be equal. You convert into sine into cos. Therefore tan theta 1 minus 2 sine square I can write as 1 minus cos square theta, that is from first identity. Now the denominator there is no change, 2 cos square theta minus 1. You see now tan theta, this is 1 minus 2 into 1 minus 2, minus into minus plus cos square theta by the denominator 2 cos square theta minus 1. Now you observe carefully. Here 1 minus 2 is minus 1. So totally we have minus 1 plus cos square plus 2 into cos, 2 cos square. Once you see 2 into 1 it is 2, minus 2 into minus cos square plus 2 cos square. Now here 2 cos square minus 1, here also 2 cos square, 1 minus 2 will be minus 1. So the both will be cancelled. Now the answer is tan theta, that is the required RHS. Now next identity to prove is sin A plus cosecant K square plus cos A plus secant square is equals to this one. You see, observe, the question is LHS part is in sin and cos and cosec, and RHS totally in terms of tan and cot. So first you should find out the relative identity of tan and cot. What is the relative identity? We have 1 plus tan square A is equals to secant square A. This is one of the identity. And second identity is, third identity is 1 plus cot square A is equals to cosecant square A. So these are the mainly identities related to tan and cot. Now LHS is this part I have taken this LHS part. Now expand this. This is sin square A plus B whole square, cosecant square A plus 2 sin A cosecant A. Next plus this value, right? Cos A, cos square A plus secant square A plus 2 cos A and secant A. Now you see sine and cosec value is sine, both are reciprocals. So one value is here, sine square a cos square a. By deleting these two I can write 1. First identity we have sine square a plus cos square a is 1, plus this you write as it is cosecant square a, plus here you see this is over, this is over. Next 2 sine and cosec is 1, therefore 2 into 1, plus this is already completed. Then remaining is secant square a plus 2 into cos and sec, reciprocals. Therefore cos theta into secant theta is also 1. Now you observe we have 1 plus 1 plus cosecant square a. So I can write cosecant square a is equals to 1 plus cot square a, plus these two you write as it is. Then secant square a is 1 plus tan square a. The lastly we have it is 2. Now you see 1 plus 1 is 2, 2 plus 2 is 4, 4, 5, 5 plus 2 is 7, plus write in order first tan square a plus cot square a. So this is required RHS. So what are the formulas used here? And here one more formula we used, that is sine a into cosec a is equals to 1 here, and cos and sec. So write in bracket, that is cos a into secant a is equals to 1. This is used. These are the requirement to solve this problem. Now this is 9th question. Here you take LHS part. LHS is cosecant a minus sine a and secant a minus cos a. You convert all the values in terms of sine and cos. Therefore cosecant a is 1 by sine a minus this is sine a, and secant a is 1 by cos a minus cos a. Now you take the LCM. LCM will be sine a, and it will become 1 minus 1 sine the, it is sine square a. Now take the LCM of cos a. Cos a 1 side is 1 minus by 1 into cos a, cos square a. Now 1 minus sine square from the first identity I can write as cos square a into by sine a into 1 minus cos square a is sine square a by cos a. You see, in this one sine will be deleted, one cos will be deleted. Therefore, now cos a into sine a is a reminder here. Sine a into cos a is the result of LHS. Okay, now you take LHS as 1. Now take RHS part. RHS is 1 by tan a plus cot a. Now you see, convert again sine in terms of sine and cos. Tan a is equals to sine a by 1 by sine a by cos a plus cos a by sine a. You see, the denominator only, just take the LCM, that is cos a into sin A. Cos will be deleted, sin into sin, it will become sin square A plus sin will be deleted, remaining is cos A into cos A, cos square A. Now you observe, this is the first identity. So I can write, already it is 1 by 1 by, it is cos A into sin A. Now if I write the reciprocal, it will become sin A or cos A into sin A. So this is equation 2. Therefore, from 1 and 2, LHS is equals to RHS. Now question number 10, this is the last question of this chapter. It is given 2 LHS, finally we should get tan square A. So first part I am taking, LHS is 1 minus 1 plus tan square A by 1 plus cot square A. The result must get this one or this one. So here I am taking this one, I am finding the value of tan square A, and the second part take this one and find this value. Now you see the answer is in terms of tan. Here this is 1 plus tan square, no problem, we keep as it is. Cot you convert into the tan. Cot is equals to 1 by tan. Therefore I can write this is 1 plus tan square A by 1 plus cot is equals to 1 by tan square A. Now take the LCM of this one. So numerator there is no change. Keep as it is 1 plus tan square A. In the denominator, again we have a fraction, that is tan square A and 1 plus tan square into 1, it will be tan square plus tan square 1 into 1, 1. This is a fraction. Now we can write this one as 1 plus tan square A into, this will be reversed. The fraction will be tan square A by tan square A plus 1. You see, the both are equal and you just cancel, and this is tan square A. So it is nothing but RHS. You see, we require to find sin. So this is first part of LHS. Then second part, another LHS part 2. So what is LHS part 2? It will 1 minus tan square A by 1 minus cot A whole square. Now just you convert this value is 1 minus tan square, you write as it is, by here 1 minus cot A. Cot A is 1 by tan A. So for both we have a square. Once we check whether this is correct or not, 1 minus, this is tan, not tan square. Check it. Now this is 1 by cot A. If you take LCM, 1 minus tan A by the denominator you take LCM, that is tan A. Therefore 1 into tan A, it is tan A and minus 1. For both we have a square. Okay, it's an important thing here, that is the numerator part, it is 1 minus tan A is there into the denominator part. If I write here, it will become tan A by tan A minus 1. For entire, we have a square. Now you see here, this is 1 minus tan A, this is tan A minus 1. This directly won't cancel, but we have a square. Now I can write, this is, expand this square to all the terms. 1, 2, 3 terms are there. 1 minus tan A whole square into tan square A by the denominator tan A minus 1 whole square. Now you see this is A minus B whole square and B minus A whole square. Both are cancelled. Why? Because we can write A minus B whole square is equals to B minus A whole square. When square is there, it is equal. When square is not there, but suppose if A minus B, which is not equal to B minus A. It's important here, don't get confusion. So I am writing A minus this, when square is there, these two will be cancelled and the resultant will be tan square A. This is RHS. This is up to this chapter.